Hello everyone, welcome back. We are doing lesson number 5 on tension in cables, strength of materials and structures, and 6. We are almost done with this topic. The only thing that is left is for us to anchor the cables. This is the structure that we have done so far, and what is left is for us to anchor this main cable to the ground. The reason why we do this is to ensure that the load of the bridge is safely transferred to the ground. And another thing, if we do not anchor these two cables, they are going to bend our two supports inward. You might find that over time, support number A is like this and support number B is like this, which is not good for the bridge, of course, because if this is going to happen, the cable is gonna go down and God knows what's gonna happen to the bridge itself. So we need to maintain the tension and to make sure that the load carried by the main cable is safely transferred to the ground. We have two methods of fixing the main cable to the supports. We have the first one, which is by using a pulley assembly, where we are going to, let me remove this out of screen. We are going to have the support, and then we have a pulley. The main cable is gonna come from this side, go over the pulley, and then to be anchored. We know obviously we're going to have the triangle that we have been drawing all along, where this is our theta, this is our FT, this is our FH, and this is our W, and I did X. And then on the anchor side, this is the angle that we are going to consider. We have alpha, and let's close the triangle. We have FVA, we have our FH anchor. Let's say this is M for main cable, and then we have FTA for anchor. Now the important things that we need to understand about this, or we need to know, is that FT of the main cable will be equals to FT of the anchor. This will be equals to this, and that is because this is still the same cable. The tension here is gonna be equals to the tension here, but FHM is not equals to FHA. Therefore, a bending moment is gonna develop because we have this not being equals to this, and these two are horizontal forces. So if this is the tower, we have FHM, let's say, pulling in that direction, and then we have FHA pulling in that direction, but they are not the same. So if this is 5 and this is, let's say, 4 newtons both sides. The resultant will be what? 1 newton in that direction. Therefore, this will tend to bend in the direction of the resultant force, causing what? Bending moment on the supports, which we are going to calculate using this formula. Bending moment, say bending moment, will be equals to h, which is the height of the tower, in bracket fh of the main cable is equal minus fh of the anchor cable, and that will give us our bending moment. And we know this will be meters, this will be newton, it will be given in newton meter. That will be the SI unit. We know bending moment is given by newton meter. And the reaction on the support is equals to Wx plus FAV. These two, they are both going down. That is why they are both positive. They are going in the same direction, the weight. Let's move these. These values, if you do not have them, or let's say you have one of them and then you have the angle as well, you are going to use trig ratios to calculate for them, and taking to consideration that this is the angle that we are going to use. We are going to use all the trig ratios. So if it's sine alpha, sine is what? SOH, which is opposite. Opposite is FHA. Hypotenuse is FTA. If it's cos alpha, it's equals to adjacent is this one, FVA. Hypotenuse is FTA. If we're using tan, it will be opposite over adjacent. Opposite is this one, tan alpha. Our opposite will be FHA. Our adjacent will be FVA. These are all the trig ratios that you are going to use whenever you want to find the information here, but you must always remember this part, because they might give you the angle and give you this FTM of the main cable. You must then know that it is equals to this one. So if you're given that and you have the angle, you can find the rest of the information. These are the formulas that are associated with the pulley assembly. Remember, we said we have two methods of fixing the main cable to the support. Let's do the next one. Going to move this and draw the support again. This is our support. Now we're going to use what we call frictionless rollers. So we're going to have something like this. We're going to say it's a trolley, and we have rolling element here. That is why it's called frictionless. This will be the main cable. This will be the anchor cable. We're going to draw those triangles of ours, and this will be the anchor. This is our theta, and remember, on the anchor, this is the angle that we use. That's alpha. Still, this is FTA, FHA, FVA, FTM, FHM, and this is WX. On this one, FTM is not equals to FTA, because you can tell that this is not the same cable. They joined the main cable here, and then they joined the anchor cable here. But FHM is going to be equals to FHA, and as a result there will be no bending moment. It's equals to 0 Newton meter. The reaction, it is still WX plus FVA, and to get the information on this side we are still going to use sine, cos, and tan theta. It's alpha, sorry. This will be, which is opposite over hypotenuse, and this will be adjacent over hypotenuse. And the last one will be tan. Let me move it, tan, which is equals to opposite over adjacent FVA. I am going to end this lesson here. It's gonna be a short one, and then on the next lesson we're going to do a question involving the anchor, so we see how do they include the anchor when they are asking questions. I will see you on the next lesson.